To solve a system of linear equations with three equations and three variables, the first thing I like to do is start out by labeling these equations 1, 2, and 3, because I'm going to end up with 5 equations total that I need to deal with, and it's a good idea to keep track. So the first thing I want to do now is decide which of these three variables I want to eliminate first. So I'm going to pick on x's, but you could just as well pick on y's or z's. And I'm going to start with the first two equations. And to get rid of x, look at what I have to do. If I've got 6x in my second equation, I want a negative 6x in my first equation, so let me just multiply that first equation by negative 6. So that leaves me with negative 6x plus 12y plus 18z equals negative 6 times 24 is 144. My second equation, I don't have to do anything because I already have my x's, so they'll cancel out. So I'm just going to rewrite it. So add these two equations together. That leaves you with 15y plus 16z equals 154. I'm going to call this my fourth equation and come back to it in a minute. Now I want to do the same process again, but this time I need to include the third equation. The third equation, and then I can pick either one of the other ones. I want to get rid of my x's again, so let me pick the second equation, but I could have picked the first if I wanted to. I've got a 6x in the second equation and a 6x in the third equation, so let me make one of those negative by multiplying by negative 1 so they cancel out. So my third equation is going to become negative 6x minus 4y plus, that's a y here, plus 3z equals negative 12. Don't forget to multiply the other side of the equal sign. My second equation I didn't have to do anything to, so I'm just going to rewrite that. Now add these two equations together and see what you get. I get a negative y, of course my x's cancel out, plus z equals negative 2. Now I'm going to call this one my fifth equation. Now notice my fifth equation and my fourth equation both have two variables. So I have two equations and two things that I don't know. So this is like what basically the easier version of these systems of linear equations. Now I want to get rid of one of the variables in these two equations with two variables. So it looks like y might be easiest to get rid of if I just multiply the fifth equation by 15. When I add them together, my fourth and my fifth equation, the y's would then disappear. So let's do that here. Fourth equation and my fifth equation, I said I'm going to multiply my fifth equation by 15 so the y's disappear. That's going to give me negative 15y plus 15z equals negative 30. My fourth equation I'm not going to do anything to because my y's will disappear. 16z equals 154. Adding these together gives me 31z equals 124. Dividing both sides by 31 would give me z equals 4. So I'm in good shape so far. I figured out that z is 4. Now to figure out what y is, I could go back to either my fourth or fifth equation, plug in 4, and see what I get. Well, my fifth equation, my original fifth equation, is going to be easiest to plug into, so let me plug it into there. I've got negative y equals, plus z, except now I know that z is 4, and that equals negative 2. So subtract 4 from both sides. I have negative y equals negative 6, so y equals 6. Alright, I'm almost done now. Now that I know z and y, I can go back to one of the original equations and pick the easiest one. It looks like this first one is the easiest one. Plug z and y in, and I'll be done. So let me do that here. If I plug, if I know that y is 6, I can say this first equation is x minus 2 times 6 minus 3 times z, but of course I know z is 4, So that's going to equal negative 24. So this is x minus 12 minus 12 equals negative 24. And that's, of course, x minus 24 equals negative 24. Add 24 to both sides, and I'll have x equals 0. So I've got my answer. 0, 6, 4.